So we've got our cliff here, and we've got our diver, just a little dot. He's going to jump into some water. So we know that he's jumping out just horizontally. It's not like he's jumping up and out. He's just jumping out. And so if we were going to draw a dotted line to represent his trajectory, it would look something like this. Follow a nice curved path into the water below.
You know what blew our mind is when he said if you shoot
Shoot a bullet and drop a rock at the same time.
Mm-hmm.
Crazy, huh? Yeah, it's weird.
I still don't. Man.
Yeah, as long as the ground's level and you shoot it parallel to the ground, totally true.
That's crazy. Yeah, I mean, it would have to be in a vacuum though. I mean, but he said they're like bullets. You shoot a bullet, it has a spin to it that keeps it. It doesn't. I don't think he said that there's like fins on it to make it, you know.
Give it some loft.
Give it some loft, but maybe there is. I don't think there is though, because that would take away from your accuracy on a bullet.
Yeah. So yeah, it's crazy stuff, but yeah, gravity doesn't discriminate. If you've got a rock or if you've got a bullet traveling, you know, however many miles per hour, it's still going to pull them both down at the same rate.
That's going to be a good demonstration for high school kids. Let's go outside. I got 30-06.
There you go.
Okay, so he's going 2.5 meters per second.
Cool. So when we say 2.5 meters per second, that's velocity is only in the x direction. It's not like it's some angled velocity where he's going kind of up and kind of over at the same time. He's just going horizontally at, what was it, 2.5?
Meters per second. And I guess we would have to, don't we take in consideration gravity here too, like 9.8?
Yeah, so so what do we call that? We'd call that acceleration.
Acceleration.
And so usually people think of the up direction as the positive direction and the down direction as the negative direction. With that kind of standard convention in mind, since gravity pulls down, it's usually easier for people to think of gravity as negative 9.81 meters per second squared. We could call it positive, we just have to be consistent. But usually people think of down as negative, so.
Okay, so back up just a hair.
Yep.
Why is acceleration that, and why isn't acceleration 2.5 meters per second?
Because this is a velocity. So it's just telling us he's going a constant 2.5 meters per second. Every second he's covering 2.5 meters of ground. Whereas this is telling us that every second their velocity is increasing by 9.81 meters per second.
Oh, I gotcha. So that's a constant. That could actually, I guess, with...
This is constant as well, but it's describing the change that's happening in velocity. So when we drop something, every second that it's falling, it's going faster by 9.81 meters per second. Yeah, so every second it's increasing by that same interval.
If it was in a vacuum, it would just go faster.
Yeah. So yeah, here with air resistance and things, we have terminal velocities, but if you had a vacuum and you had a bottomless pit, if you drop something, it could get up to, you know, infinity speed. Cool. Yeah, it'd be cool, huh?
Okay, how high was the cliff?
Does it matter that he hit the water 3.1 seconds later?
Yeah.
Yeah.
So this is how I like to set up these types of questions. It's pretty easy to recognize that there's two significant points in his trajectory, the initial point and the final point. All this other stuff is like cool, like yeah, he like went through that point or whatever, but these are the significant points as far as labeling them with variables and analyzing them. So let's go ahead and take this initial point and this final point and label it with the variables that we hopefully are getting used to by now. I'm going to change that to down here. So this point can be labeled with a number of different variables. We can label it with an x naught value, a y naught value, a velocity naught value in the x direction, a velocity naught value in the y direction, and a t naught value. Any questions about those variables or what they mean?
Kind of, but no. I guess. I don't know.
So the trickiest one usually for people is the v naught x and the v naught y. So that's just saying, like, you know, if we had a soccer ball and they said that we kicked it up at some angle at 20 meters per second, we would want to, because that's a diagonal vector, we don't like diagonal vectors, right? So we'd split it up into a horizontal component and a vertical component. And so we'd say, okay, initially the ball was kicked with, you know, however much this ends up being.
V naught x and v naught y.
Exactly. So we'd split this velocity, just regular old velocity, into an x velocity and a y velocity. And we'd keep them separate because they're independent of each other. Because in projectile motion in particular, y velocity changes because of gravity. But x velocity, in 105 at least, when we ignore air resistance, it stays constant because there is no acceleration in the side-to-side dimension. There's nothing causing that soccer ball or this diver to speed up or slow down in the x dimension.
Only air, and they're taking that out.
And yeah, we ignore that for the most, well, always in 105. But in the vertical dimension, there's definitely acceleration. We've got gravity that we have to deal with. So it's useful to break x apart from y, because then we can say, okay, we'll just leave x constant, but y we need to worry about because we've got this thing called gravity that's going to be playing with it. So that's why we take the time to say, we're not going to deal with just regular old velocity. We're going to deal with velocity in the x dimension and velocity in the y dimension.
Okay.
Cool. So x naught, what do we want to call his starting x position? We usually call that 0 meters, unless there's some reason why it's not smart to call it 0 meters. So we're just saying we're going to start our, you know, measuring tape here, and then as he goes out this way, it'll be some positive value. The y naught, usually we'd say, you know, the water is the 0 mark as far as the vertical axis. We don't know how high he is. That's what it's asking for, so we can't put a value here yet. V naught, his initial velocity in the x dimension, we know is 2.5. His initial velocity in the y dimension is what? How fast at this instant is he moving up and or down?
0.
Yeah, he's not doing anything yet. The very next instant in time, he'll have some downward velocity because gravity will have started to play on him. But for right now, it's a nice, easy to work with 0. T naught, we always call 0 seconds. That's when we start our theoretical stopwatch. So as far as initials go, the only thing that we can't really put a value for is his starting height, and we'll solve for that. That's what the question's asking for.
Okay.
Over here, just quickly, we can do all the same variables, but now we won't put a little not symbol because these are the final values. So we have x, y, vx, vy, and t.
And those are finals.
Yep. So here, we don't know what x is because we don't know how far out from the cliff he jumped. We do know that y is now 0 meters because now he's at that 0 meter mark, the water. Vx is what? What's his velocity in the x direction?
It should be, it's the same.
Good.
2.5 or at 0. But
Yeah, so it hasn't changed at all because there's no acceleration in the x direction. So maybe we can even say a sub y over here because this acceleration only takes place in the y dimension. And a sub x, which we don't usually take the time out to write, but
0.
it would be 0 if we were going to write it out. His velocity in the y dimension, don't know. The time, we do know from the question, was
3.1 seconds.
3.1 seconds. So now I like this because now not only do I have kind of a picture to help wrap my mind around, but I also can really easily see what I know and what I don't know. So now what I usually like to do is just, if I have the kinematic equations written down somewhere, I look at those, or if I don't, I just write them out and I start asking myself which one has the variable that I'm looking for and which one has variables that I have values for that I can use. So our kinematic equations are x, well, let's go ahead and do the y version. So y equals y naught plus v naught t plus 1/2 times a times time squared. V equals v naught plus a times t. V squared equals v naught squared plus 2a times change in y. Or we can say
You got your book.
y minus y naught.
Vertical motion, horizontal motion. Vertical motion, horizontal motion. So, why is there two different ones? Horizontal motion, because we're doing both right now, right?
Mm-hmm.
Uh-huh. So we always split them up, and we don't usually look at v and x at the same, or v and y at the same time, because it gets confusing. That's like the diagonal stuff. We like to just deal with the easy stuff. So we look at just what's going on in x, and then separately we look at what's going on in y, and then we just combine them at the end to get the full effect. So right now we are just looking at y, really, because it wants to know how high the cliff is. That's a y type of question, right? The x dimension has nothing to do with height. So looking at that, we know that we are really interested in finding out what y naught is. So the first thing we want to do is look at our equations and see if any of them don't involve y naught. This middle one doesn't have y naught in there. So that's not a very effective equation to use because it doesn't have the variable that we're after.
So those equations can be interchangeable with x and y. You just
Yep, anywhere where you see a y, you could just as correctly put an x.
Okay, and that's the way you figure out your vertical and your horizontals. Okay.
Yep, but you never put an x and a y. So these would either both be x's or both y's. Same here. Cool.
So number 2 is out of the question.
Yeah, so this one's no good because it doesn't help us get closer to our answer. If we look at this one, we don't know, or we do know y, that's 0. We don't know y naught, that's what we're after. We do know v naught. We do know t. We do know acceleration. And we know t. So that one will totally work because we have all the variables that we need except for the one that we're after. Down here, we would run into a problem because we know v naught in the y direction was 0, but we don't know what v is, what v final was. And so even though we know a and we know y, we end up having two variables that we can't solve for in this one. So this is going to be our winning ticket for this case.
And whenever it's just y by itself or v by itself, that would be a v final?
Exactly. So the absence of the little not symbol means final. Sometimes they write sub f, but it's just as correct to write nothing if you're consistent.
Okay.
So let's go ahead and plug into that equation. We know that y was 0 equal to y naught, which is what we're after. V naught was 0, so 0 times anything is just going to be 0 for that term. And then 1/2 times negative 9.81 times 3.1 squared. So we end up getting 0 is equal to y naught minus 47.13. So then we add this over to the other side, and we get 47.13 equals y naught. And the units on that, meters. So pretty daring diver. That's a pretty tall cliff to jump off of.
Yeah, that's
It's like 150 feet, yeah.
Yeah.
So I would
Yeah,
not.
that's what I was telling kids doing boards in the class, and I was like, that's like 150 feet, man. I think they can dive that. I know that they've done 120, 130. Oh, man.
Yeah, that would be scary. I would not be able to do that.
I've known guys who jumped off 100-foot cliffs, and they say you actually have time to think when you jump that high.
Yeah.
You know, it's just there's
Yeah,
no
'cause I mean,
jump and hit. It's
3
you actually have
seconds.
time to.
A whole breath, and then you have to suck back in, and then you're like, ooh.
Yeah, that's scary.
So
So to find that x one, would you do the exact same equation then?
So the
Except
x
you
one.
switch out the x's?
The x one becomes really easy because in the x direction there's no acceleration, so this whole term goes to 0. Our x naught term is 0, so that term goes to 0.
Mhm.
So it pretty much just becomes a simplified equation where we say x is equal to v naught times time.
So 2.5 times time.
Exactly.
And time was what, 3.1?
Mhm.
Which is 7.8.
Yep, so 2.5 times 3.1. But yeah, it's the same equation, it just, a lot of things end up going to 0 because of the absence of acceleration.
Nice.
Sweet.
So what did that end up being for the x direction?
Yeah, 7.8.
7.8?
Mm-hmm.
So that gives me a lot more information.